Good day, everyone. Today we will work with Kubernetes and Jenkins on Google Cloud. So let's start. Let's search here for Kubernetes and Jenkins terms. Okay, so we will go through this lab, continuous delivery with Jenkins in Kubernetes engine, which is also a part of this quest, DevOps Essentials. If you go through all of these labs available in this quest, you will get this nice badge you can show off on your social networks, for example. So let's start the lab from here. In my case, as I'm leveraging my partner account, this lab shows as free. I'll attach the regular skills, Cloud Skills Boost URL in the video description, and please bookmark this URL here for information on promotional offers through which you can get free credits. For these Qwiklabs and Arcade, as you can see. Okay, let's go back to our lab and start it. I won't do all of the reading, but we'll skim through the lab instructions and focus on the hands-on commands. As you see, we have 1 hour and 15 minutes to our disposal. And on the right side, we can see we have 13 tasks to go through. Okay. In the new window, we will work here. Okay, we logged in to our dashboard. We now see, yeah, I have this disposable student account. I won't spend any of my personal credits attached to my partner account. So, overview of the lab. In this lab, you will learn how to set up a continuous delivery pipeline with Jenkins on Kubernetes engine. Jenkins is the go-to automation server used by developers who frequently integrate their code in a shared repository. The solution you'll build in this lab will be similar to the following diagram. Okay, we are missing the last part of the image, but let's open image in the new tab. Let's see if we can see it. Yeah, as a whole. Okay, this is the lab topology. In the Cloud Architecture Center, see Jenkins on Kubernetes engine to learn more about running Jenkins on Kubernetes. Okay, you go through that on your own time. Let's focus now on practical commands. Okay, here the practical part starts. So we here first see we have this GCP project ID. Let's start our Cloud Shell terminal. Let's define our project ID. Okay. I'll periodically clean the Cloud Shell terminal here, so you can see all the commands clearly, not at the bottom of the screen. Okay, task 1, download the source code. Task 2, provisioning Jenkins, creating a Kubernetes cluster. Okay, it says this step can take up to several minutes to complete. The extra scopes enable Jenkins to access cloud source repositories and Google Container Registry. The cluster is being configured in working state, so ongoing state, not yet finished. So when that gets completed, we can click check my progress to verify performed task. If you have successfully created a Kubernetes cluster, you will see an assessment score. Okay, on the right side we can see we are currently at 0 out of 100 points. We are aiming to get all 100 points. Still created. Okay, but let's skim through the instructions. In upcoming instructions, before continuing, confirm that your cluster is running by executing the following commands. Get credentials for your cluster. Kubernetes Engine uses these credentials to access your newly provisioned cluster. Confirm that you can connect to it by running the following command. Next, task 3, set up Helm. In this lab, this task, you will use Helm to install Jenkins from the charts repository. Helm is a package manager that makes it easy to configure and deploy Kubernetes applications. Once you have Jenkins installed, you'll be able to set up your CI/CD pipeline. Okay, we have to add Helm's stable chart repo for Jenkins, and then the repo is up to date. Task 4 will be configure and install Jenkins. When installing Jenkins, a values file can be used as a template to provide values that are necessary for setup. You will use a custom values file to automatically configure your Kubernetes cloud and add the following necessary plugins: Kubernetes latest, workflow multi-branch latest, Git latest, configuration as code latest, Google OAuth plugin latest, Google source plugin latest, Google storage plugin latest. This will allow Jenkins to connect to your cluster and your GCP project. Use the Helm CLI to deploy the chart with your configuration settings. This command will also take a couple of minutes to complete. Then we'll test the completed task. Once the command command completes, ensure the Jenkins pod goes to the running state and the container is in the ready state. With this command, we see here example output, configure the Jenkins service account to be able to deploy to the cluster. And we should receive the following output. Then run the following command to set up port forwarding to the Jenkins UI from the Cloud Shell and check that the Jenkins service was created properly. With this command, and this is the example output, you are using the Kubernetes plugin so that our builder nodes will be automatically launched as necessary when the Jenkins master requests them. Upon completion of their work, they will automatically be turned down and their resources added back to the cluster's resource pool. Notice that this service exposes ports 8080 and 50,000 for any pods that match the selector. This will expose the Jenkins Web UI and Builder Agent registration ports within the Kubernetes cluster. Additionally, the Jenkins UI services is exposed using a cluster IP so that it is not accessible from the outside cluster. Okay, we see here the cluster is created, the master is healthy, done. Okay, let's get back to our desk. Where did we post? Okay, here. Now we see we have 30 out of 100 points on the right side, but let's check my progress over here also. Okay, great. It accepts assessment completed. So let's run through all of these commands. This is also the part where which can take up to a couple of minutes to complete. So while we are waiting on that, I can mention a couple of Kubernetes related resources for you to check out on your own. Kubernetes the hard way, optimized for learning, which makes taking the long route, which means taking the long route to ensure you understand each task required to bootstrap a Kubernetes cluster. Also, Alok Kumar's YouTube channel with Kubernetes resources. Then OWASP Kubernetes Top 10, Madhu Akula's Kubernetes Ghost, and resources from Omar Santos' GitHub repository related to Kubernetes security. And that's about it for now. Okay, after a couple of minutes, the command finishes and we can proceed. Okay, we're still here at 30 points, so let's check the part here where we expect to see 20 out of 20. So let's force the manual check. With the manual check, Okay, it accepts now, and also check here. Great. Now we are at 50 out of 100. So let's proceed. I once ran this lab and didn't make it until the end because my time ran out. So let's go faster this time. The thing here is that you cannot extend the lab time, but you have to start all over again if you don't make it until the end and don't get all 100 points. So task 5 is connect to Jenkins. Okay, let's retrieve admin password with this command. Okay, we have it here if needed. Now let's go to the Jenkins user interface with the web preview on port 8080. Great, it immediately lands us onto admin's dashboard. No need to enter the credentials. Task 6, understand the application. You'll deploy the sample application gsim in your continuous deployment pipeline. The application is written in Go language and is located in the repos sample app directory. When you run the gsim binary on a computer engine instance, the app displays the instance's metadata in an info card. Okay, we expect to see something like this. The application mimics a microservice by supporting two application modes. In backend mode, the gsim listens on port 8080 and returns compute engine instance metadata in JSON format. In front-end mode, the gsim queries the backend gsim service and renders the resulting JSON in the user interface. Deploying the task 7, deploying the application. Okay, you will deploy the application into two different environments: production, the live site that your users access, and canary, a small capacity site that receives only a percentage of your user traffic. Use this environment to validate your software with live traffic before it's released to all of your users. Okay, we now see here deployments and services are created, but we are still here at 50 points. So let's let's force the manual check. This part, yeah. Still showing as 0. But we ran all of these commands without an error. Okay, now shows as assessment completed. Let's try again over here. Okay, now it accepts. Great. Now we're on 80 out of 100. Okay, check complete, points earned, message assessment completed. Great, let's continue. Let's scale the deployment with 4 replicas. The deployment scaled. Okay, we should see now 5 pods for front end with this command. 1, 2, 3, 4, 5, all in running state. Great, we want to see the running state. On the backend, 2 pods. Okay, confirmed. Retrieve the external IP for the production services. External IP, we see it here. Okay. Okay, now we should see this info card. We copy paste the external IP in new tab. Great. Let's proceed. You have now successfully deployed the sample application. Next, you will set up a pipeline for deploying your changes continuously and reliably. Task 8, creating the Jenkins pipeline. Creating a repository to host the sample app source code. Create a copy of the gsim sample app and push it to the cloud source repository. Okay, here is the Kubernetes plugin for Jenkins and the cloud source repositories info. Those are fully featured private Git repositories hosted on the Google Cloud. Ignore the warning, you will not be built for this repository. Okay. Okay, safely ignore it. Check if the task is completed. Great. Okay, here we will, for the email address and username, use our credential here on the left side. So replace the defaults on the instruction. Now part adding your service account credentials. Configure your credentials to allow Jenkins to access the code repository. Jenkins will use your cluster service account credentials in order to download code from the cloud source repositories. In the Jenkins user interface, click Manage Jenkins in the left navigation, then click Manage Credentials, then System. Okay. Manage Jenkins. Manage Credentials. System. Global credentials, add credentials, Google service account from metadata, from the kind drop-down and click create. The global credentials has been added. The name of the credential is the project ID. This one found in the connection details section of the lab. Okay. Add credentials. And create. GCP 04, yeah. Okay, it matches. Great, we can proceed. Configure Jenkins Cloud for Kubernetes. In the Jenkins user interface, select Manage Jenkins, Manage Nodes and Clouds. Configure Clouds, add a new cloud and select Kubernetes. Click Kubernetes Cloud Details. Okay. Configure clouds, add a new cloud. Okay. Oh, this is double one. Okay, we don't need this one. Kubernetes Cloud Details. Okay. In the Jenkins URL field. Okay. Enter the following value. Jenkins URL. So not Kubernetes URL, Jenkins. Okay, Jenkins URL. And Jenkins tunnel field. Click Save. Creating the Jenkins job, navigate to your Jenkins user interface and follow these steps to configure a pipeline job. Dashboard, new item. Name the project sample app. And choose the multi-branch pipeline option and click OK. New item. Multi-branch pipeline. OK. Next page, in the branch sources, select Git from Add Source dropdown. Add Source dropdown, Git. Paste the HTTPS clone URL of your sample app repo in cloud source repositories into the project repository field. Replace project ID with your project ID here on the left side in the project repository field. Project repository. Okay. On the credentials dropdown, select the name of the credentials you created when adding the service account in the previous step. Under Scan Multi-Branch Pipeline Triggers selection, check the periodically if not otherwise ran box and set the interval value to 1 minute. Your configuration job should look like this. Then click Save, leaving all other options with their defaults. So options can multi-branch pipeline triggers, multi-branch pipeline, okay, triggers here, check, not 1 day but 1 minute, and other options are staying as default, save. After you complete these steps, a job named branch indexing runs. This method job identifies the branches in your repository and ensures changes haven't occurred in existing branches. If you click sample app in the top left, the master job should be seen. The first run of the master job might fail until you make a few code changes in the next step. With this, you have successfully created a Jenkins pipeline. Next, you'll create the development environment for continuous integration. Okay, with this, we got all 100 points, but we'll go through all the 13 tasks. So task 9, creating the development environment. Let's proceed with copy-pasting the commands, create the development branch and push it to the Git server. Okay, here, wait. Modifying the pipeline definition. Okay, open the Jenkins file in your terminal editor, for example, VI. So let's confirm we are in the right directory here. We see the Jenkins file, okay. What do we have to do? Start the editor with the I command. Add your project ID to the replace with your project ID value, okay. Your project ID, okay, on the left side. You can also run this command to find it. Change the value of cluster zone to US East 1D. You can get this value by running this command. Then save the Jenkins file, hit escape. Then for VI users, WQ, write quit. Okay, short for, yeah, that. Okay, so start the editor. We started it. Oh, we opened the VI. So start the editor with I. Okay, we see now here insert, and okay, let's replace the project ID. Project ID. And then cluster zone here is US East 1D by default. US East 1D. Yeah, looks the same. So save it, then okay, escape. We don't see insert anymore. On, right, quit, enter. Okay, let's confirm with cat. Okay, it's saved. Modify the site. We here have to change the two instances of div class card blue with orange instead of blue. Save it. Okay. Two places. So I here for insert. Okay, let's replace. Okay. Blue with orange in two places. And here, that should be it. Escape. On, right quit, enter. Okay. Then open main goal. Okay, we'll also edit that. The version is defined in this line. Okay, update it to the following. So 2 instead of 1. Save it. Okay, we are looking for 100. And okay, escape. Right click. Okay, task 10, kick off deployment. This will kick off a build of your development environment. After the change is pushed to the Git repository, navigate to the Jenkins user interface where you can see that your build started for the new feature branch. It can take up to a minute for the changes to be picked up. After the build is running, click the down arrow next to the build in the left navigation and select console output. Check the output of the build for a few minutes and watch for the kubectl -- namespace equals new feature apply message to begin. Your new feature branch will now be deployed to your cluster. Okay, in a development scenario, you wouldn't use a public facing load balancer. To help secure your application, you can use kubectl proxy. The proxy authenticates itself to the Kubernetes API and proxies requests from your local machine to the service in the cluster without exposing your service to the internet. If you didn't see anything in build executor, not to worry. Just go to the Jenkins homepage sample app, verify that the new feature pipeline has been created. Once that's all taken care of, start the proxy in the background with this command. Okay, we have here now new feature in progress. Let's try with this kubectl proxy and if it stalls, press Ctrl+C to exit out. Verify that your application is accessible by sending a request to localhost and letting kubectl proxy forward it to your service. You should see it respond with 200, which is the version that is now running. Okay, try it out. Okay, there's an error. Okay, if you receive a similar error, it means your front-end endpoint hasn't propagated yet. Wait a little bit and try the curl command again. Move on when you get the following output, okay, showing 200. And with that, you have set up the development environment. Next, you will build on what you learned in the previous module by deploying a canary release to test out a new feature. Okay, let's skim through while we are waiting for the new feature related job to finish. Let's skim through uh, upcoming tasks. Task 11: deploying a canary release. So we'll have you have verified that your app is running in the latest code. In the development environment. So now deploy that code to the canary environment. Create a canary branch and push it to the Git server. Then in Jenkins, you should see after running these commands, you should see the canary pipeline has kicked off. Once complete, so we have to wait for its completion. You can check the service URL to ensure that some of the traffic is being served by your new version. You should see about 1 in 5 requests in no particular order, returning version 200. Yeah, so after running these commands, it says if you keep seeing only 100, try running the above commands again. Yeah, but after the jobs related to Canary pipeline, yeah, finish. Once you verify that above works, end the command with Control C. That's it. You have deployed a Canary release. Next, you will deploy the new version to production. Let's try the curl command once again. Yeah. Still showing an error. Okay, let's wait a bit more. Task 12: deploying to production. Now that our Canary release was successful and we haven't heard any customer complaints, deploy to the rest of your production fleet. Create a Canary branch and push it to the Git server. In Jenkins, you should see the master pipeline has kicked off. Once complete, which may take a few minutes, you can check the service URL to ensure that all of the traffic is being served by your new version 200. Once again, if you see instances of 100, try running the above commands once again. You can stop this command by pressing Ctrl C. Example output, we want to see something of this sort. You can also navigate to site on which the GSIM application displays the info cards. The card color changed from blue to orange. Here's the command again. To get the external IP address, paste the external IP into a new tab to see the info card displayed. And this is the example output. We expect to see something of the sort. And task 13 is test your understanding. Below are multiple choice questions to reinforce your understanding of this lab's concepts. Answer them to the best of your abilities. What are the following Kubernetes namespaces used in this lab? Is it production, Jenkins, default, kubesystem, or Helm? So a multiple choice question. And one more question. The Helm chart is a collection of files that describe a related set of Kubernetes resources. Is this statement true or false? After that, we are done. Awesome job. You have successfully deployed your application to production. Let's see what's the state in the Jenkins UI. Okay, new feature is now completed. Let's try once again with this curl command. Great, we now see the desired output. 200. Let's go back to task, was it 11 where we stopped? Oh no, 10. Okay, we now see this output. Okay, now task 11. Let's quickly copy paste the commands. Okay, after this command, Canary pipeline in Jenkins should be kicked off, and we are also now waiting for it to complete. So that this was the blue one, info card, and now here. Okay, not yet. Okay, we ran these two commands: git checkout canary branch and git push origin canary. Looks good from here. And then this should kick off canary pipeline. Okay, yeah, great. So while we are waiting on that to complete, let's read the congratulations message. This concludes this hands-on lab deploying and working with Jenkins in Kubernetes engine to enable a continuous delivery, continuous deployment pipeline. We had the opportunity to deploy a significant DevOps tool in Kubernetes engine and configure it for the production use. You worked with Qwiklabs or kubectl, how some call it, command line tool and deployment configurations in YAML files, and have learned a bit about setting up Jenkins pipelines for a development deployment process. With this practical hands-on experience, you should feel comfortable applying these tools in your own DevOps shop. Okay, Canary now. Canary jobs related to Canary branch completed. Now let's go back. Okay, we should now see about 1 in 5 requests showing 200 after copy pasting these commands. Great. 200 starts to show up. Okay, task 12. Let's run through these commands, deploying to production. After running this command in Jenkins, you should see the master pipeline kicked off. So now we expect to see all of the traffic being served by the new version 200. Once again, if you see instances of 100, try running the above commands once again. Yeah, once complete, okay. Once again, might take a couple of minutes. And the finishing message: this self-paced lab is the part of the Kubernetes in the Google Cloud, cloud architecture, and DevOps essential quests. A quest is a series of related labs that form a learning path. Completing a quest earns you a badge to recognize your achievement. You can make your badge or badges public and link them to your online resume or social media account. Enroll in any quest that contains this lab and get immediate completion credit. See the Google Cloud Skills Boost catalog to see all available quests. Take your next lab. Continue your quest with Hello Node Kubernetes, or check out these Google Cloud Skills Boost labs, such as orchestrating the cloud with Kubernetes and the managing deployments using Kubernetes engine. Meanwhile, in the Jenkins UI, okay, we now see the master branch now in progress. So the previous build, the first one, failed, as mentioned in the lab instruction should be expected. Now the second build, if we click on this down arrow, we can see the console output. Okay, great. Now it's jobs related to the master branch successfully completed. So now we expect to see only 200, showing output as expected. Okay, now we need the external IP. So we remember, yeah, we previously saw this blue info card and now we expect to see the orange. Great. So let's test our understanding. Which are the following Kubernetes namespaces used in the lab? So we are interested here in Kubernetes namespaces. If we don't remember out of these, let's run the terminal command. So kubectl get namespaces. This is the output showing default, kube node release, kube public, kube system, new feature, and production. And from the offered, okay, production, default, kube system should be it. Great. And the next one, the Helm chart is a collection of files that describe a related set of Kubernetes resources. That should be true. Great. So for the next steps, it is recommended to read further on the Jenkins in Kubernetes engine solution, learn how to use Jenkins to enable continuous delivery to Kubernetes engine, read further on DevOps solutions and DevOps guides in the Google Cloud documentation, and connect with the Jenkins community. With this, we can end this lab. I hope you enjoyed this walkthrough. Until next one.